S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, what are the properties of laser? Why it is more intense? What is its direction? So that will be understand in the upcoming topic. Myself Narendra Kaur. So let us begin this characteristics of laser. That means properties of the laser. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. So these are the few characteristics of the laser light. So by which we can understand what are the properties of the laser. So how intensity of the laser light, that is very large. It moves only in the one direction. So now the first are the few properties of the laser light like this. First property, that is the coherence. Laser lights are highly coherent in nature. Coherence, that is one of the unique property of the laser light. It arises from the stimulated emission process. We know that in case of laser light, so if this is a laser light, so there occur the few steps like this. One, when the laser light, when the sum of the light is falling on the atoms which are present in the ground state, so atoms will jump from this ground state to the excited state. So the atoms will jump from ground state to the excited state. So this is called stimulated absorption. Now the atoms can jump back from the, here the atoms can jump back from this excited state to the ground state. Then some amount of radiation is also emitted. So this is called incoherent radiations. Means the different radiations are emitted in this case with a different wavelength or the frequency. They are not of our use. Also for the atoms, there exist some metastable states. So atoms can directly jump from excited state to the metastable state by the non-radiative transitions. So these are the called non-radiative transitions. Then again these atoms now, they are stable over here. This is called metastable state. Means the metastable states, atoms are more stable than in the ground state level. Now for the atoms to come back from this to this state, some amount of the energy or the external force is required. That means these atoms now, some force or the energy is required in the form of radiations. Then these radiations will make back transitions of the atoms from metastable state to the ground state. And the difference of these two, if this is energy E3 and E1, then the photons will be released in this case with energy E3 minus E1. So this kind of photons are released over here. Now you can see that here some amount of energy is required for the atom, and when the atoms jump from excited state or metastable state to the ground state level, the radiations which are emitted in this case, they are coherent in nature. That means these radiations travel in the one direction with one wavelength. So here the wavelength of these radiation is fixed. The wavelength is fixed in this case. So that's why in the stimulated process, the coherent radiations are produced for the laser. So this is one of the important characteristics of laser. So the first characteristics is that the coherence is one of the unique property of laser light, and it arises from the process of stimulated emission, because in the stimulated emissions, atoms come back from metastable state to the ground state by the absorbing some photons. Then the photons get released, so the energy density of the photons goes on increasing, and after the multiple transitions or the multiple reflections and transitions, we will get the laser light. Now second is the monochromicity. That means a laser beam which is produced, that is mostly in the of single wavelength. That means the line of width that is extremely narrow over here. Line width means the light, the wavelength, the laser which is travel in the one direction. So that means the laser will travel only in the one direction over here. The spreading in the wavelength, that is very small over here. While in case of ordinary light, the light spreads over the large area. When it spread over the large area, its wavelength, that will be more angle of divergence for the wavelength is also present. That means for the ordinary light, the usually the spreading is 1 in 10 raised power 6 over here. But for the laser light, that is ratio is 1 is to 10 raised to power 5 over here. That means the laser light is more monochromatic than the ordinary light. So also the width of line for the laser light, that is 1 hertz in this case. So the 1 hertz means that is quite large over here. So that's why the laser radiations are said to be highly monochromatic. So these radiations are highly monochromatic. So that's why the laser light is preferred over the ordinary light. While for the ordinary light, the angle of divergence for the wavelength, the spread of divergence for the wavelength, that is large for the ordinary light and which is 10 factor smaller in the laser light. So that's why the laser lights are highly monochromatic. Next is the directionality. That is an important feature in case of laser light, because we know that the laser beams, they are highly directional, because the laser emit light only in the one direction here. So one direction means it travel only in the one direction. So if this is the laser light, so the angle of divergence for this laser light, that is quite small. So that means its spreading is very small over here. If this theta represents the angle of divergence, and this is for the laser light, and here this is for the ordinary light. So if this is the theta 2 and there is a theta 1, so angle of divergence theta 1, that is quite very much less than theta 2, means this is for the laser light and that is the ordinary light. So this implies that for the laser light, the angle of divergence is very small. So that means angle of divergence means the angle which represents the spreading of light over the large area. This represents the spreading of light. We know that the laser light, it travels only in the one direction, while for this ordinary light it spreads over the large space. That is due to the angle of divergence. So also the laser light, they can travel over the long distance without any divergence. The directionality of the laser beam, that can be expressed in the terms of divergence. Now if R1 and R2, these are the radius of the laser beam at the distance D1 and D2 from the laser. Means if R1 and R2, that is we know that the laser light is traveling over here. If this is here the laser light, that can be represented like this. That means if the laser light is traveling over here, if this is the at a distance, this is the D1 distance of laser light from the initial source, and this distance is here this is a D1. Now if this distance is D2 for the laser light, now this is a D1 and D2. Now if this at this point the laser light has radius R1, at this point the laser light has radius R2, then the angle of divergence delta theta, that can be represented as R1 minus R2, or you can say that is divided by D2 minus D1. So this is defined as the angle of divergence. So angle of divergence, that is equals to R1 minus R2 divided by D2 minus D1. That is a radius, and this is a laser light radius at the point this A. You can say that this is a A point and this is a B point. So this is a radius at the point A, radius at the point B. This is a distance at the point A from initial, and this is a distance for the point A and B. Now the angle of divergence for the laser light, you can clearly see that this angle is very small over here. So this angle is mostly theta, and the angle of divergence is 0.01 milliradian, which is quite small. So that's why in case of radian it is, here it is a 0.01 radian. So that means the laser lights are highly directional. Their angle of divergence is very small. While in case of ordinary light, you can see that this angle is 0.5 radian. So this is very much large for the laser light. So that's why laser light is highly directional. Next is the high intensity. We know that the laser light they are highly intense in nature. Why this is so? Because in case of laser light, there occur multiple reflections, multiple transitions, and transmission is taken place. So due to this, it's a laser beam that is of highly intensity. That means the laser beam has lot of energy which is concentrated in the small region. Here over the very small region or over the very small radii, the laser light that is get concentrated. So that means the energy per unit volume for the laser light that is very large, or you can say that the energy per unit area for the laser light that is quite large because of smaller radii of the laser light. So that's why its intensity is very large. While in case of an ordinary light, its angle of divergence or spreading is very large for the ordinary light as compared to the laser light. So that's why energy per unit area for the ordinary light that is quite small. So that's why intensity of the laser light that is very large. Now it is also seen that the laser power that is 10 to 13 watt for the gas laser, that means for the helium neon laser, which is very high, while it is 10 raised per 9 plus 9 watt for the pulsed solid state laser, and their diameter is about 1 mm. That means the diameter of laser light that is 1 mm, which is very small, and their power which is 10 raised per plus 9 watt, which is quite large. And when we calculate its power density, that is the power per unit area, that is again becomes very large. So that's why intensity of the laser beam is very large over here. So the laser beam has important characteristics like that coherent, they are highly coherent. So that's why it is preferred. Monochromicity means these radiations are with highly monochromatic with a single wavelength. Only single wavelength laser lights that can be produced by using the stimulated emission. Next, these lights are highly directional in nature. There are lesser angle of divergence. Next is the intensity of the laser light. So that is quite high because the power density per unit area for the laser light that is quite high. So that's why they are having the high intensity. Now we will take a short break. So till now we have understood what are the properties of the laser beam. Then after the break we will understand what are the applications of laser beam.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to the S. Chand Academy. Now before going to the break, we have understood what are the properties of laser beam or the characteristics of laser beam. Now we will understand what are the applications of laser beam. So now these are the important applications of the laser beam. We know that due to its important properties like they are highly diverse in nature, they are monochromatic, directionality is very high and also with a high intensity. So there are the certain area where the lasers are mostly or the widely used. So first area that is in the communication. So the laser beams are highly used in the communications. So first is the laser beams, they can be used in the optical fiber communication. We know that when the ordinary light is used, so it cannot be travel for the longer distance. So in the midway, the light that will be diminished. But in order to travel the signals for the longer distance, we need a light which can travel by the longer distance or having the high intensity and more directional. So that's why the laser beams are preferred. We know that the optical fibers, in the optical fiber communication, that communication is done for the kilometer range. That means the optical fibers, they are used with the length in the kilometers. So that's why the laser beam is preferred in this case. That means in this case they are used to transmit the audio and the video signal. That is happen in case of the optical fibers. So the optical fibers are used to transmit the audio and the video signals for the longer distance, the distance that can be in case of in kilometers. So that's why the laser light is preferred in this case. Also in case of the optical fiber, their diameter is taken from 0.2 to 10, their diameter is taken from 0.2 to 10 mm. So that is varying from 0.2 to 10 mm, and we know that the diameter of the laser beam also lies within this range. So that's why the laser lights are preferred in this case. Also we know that the angular spread of the laser beam, that means the angle of divergence. The angle of divergence for the laser beam, that is very small, that is around 0.01 radian. This theta angle of divergence, that is very small for the laser beam. So that means when the laser light, it can't spread over the large area, its intensity at the initial and the final point, that will remain the same. So that's why the laser light is used for the optical communication. Also the laser light, these are not absorbed by the water. So that's why the underwater measurements or inside the sea, the communication network, the laser lights are also preferred in this case. So that means when the underwater measurements of the communication networks are used, so for that case the laser radiations are also get used. So these are the important application of laser, that means the laser light that can be used in the communication skills. Next is the industrial application. Now in the industrial application, we know that some industries, they are used for the cutting, welding of the metals, and some for the surface treatment. So in that case the laser beams are preferred. So the lasers are used in the metal cutting, for welding, surface treatment and the hole drilling. That is due to the properties of the laser which are highly directional in nature. So that and highly intense. So highly intensity and highly directional. The intensity of the laser beam, that is very high, and also they are highly directional in nature. So they are highly directional in nature. So that's why due to these two properties, the laser beams, they are used in the industries. Also we know that in order to cut the material in the desired shape, in the desired surfaces, these lasers are used. Now if we want to cut the diamond in the required shape or without breaking the diamond, so in that case the laser cutting is preferred, because lasers, they are highly intense and highly directional. So that's why due to their low angle of divergence, the proper cutting of the material or the alloys, that can be done by using the laser. Then next is the welding process, that can be carried by using the laser beam. Now in order to done welding for the dissimilar metals, dissimilar metal means one of the metals when they are with the different properties, and how to combine these two metals, that can be done by using the lasers. Laser is also used for the selective heat treatment for the desired part of the automobile industries. Also in some of the electronic components, while for example in the ICs, in order to trigger their proper components and the trimming their components, for that means at the nano level the lasers can also be used. So next is the medical applications. So that is an important part for the laser beam, how in the medical industry we are using this laser. So the laser can be used in the medicines to improve the precision work like surgery. We know that in the most of the cases, or you can say that the stitchless surgery, that can be done by using the laser. So because the laser, here we are using the monochromaticity of the laser and the highly intensity, because we know that the laser beam are with a high intensity. So that's why they are used in the medical industry also. We know that some part of the or the discoloring of the skin. Some parts of that can be removed by using the unfocused layer, because otherwise our skin will be burned. So unfocused layer that will be used. So less painful, and the stitchless surgery that can be done by using the laser. Next is the cosmetic surgery. In the cosmetic surgery, like in order to remove the wrinkles, birthmarks and hairs, for all these purposes the laser beam that is used. So we know that dermatology that also been used the ruby laser, which gives us 694 nanometer. So this types of laser that can be used, different type of lasers that can be used without using any stitches over there. Eye surgery that can be done by using this laser. Soft tissue engineering that can be done by using the CO2 or this CO2 laser or the ND-YAG laser. So that can be used over here. Next is a dental procedure that can be done by using this laser. Also in order to remove the tumors, so that can be done by using the laser. This is also called non-touch surgery by using this laser. So the laser that is importantly used in the large number of applications. Now next is the use of laser in the scientific research. So how the laser is used, we know that in the scientific parts, when we are forming some components or some alloys or the 2D materials, how we can distinguish what kind of materials are synthesized in the lab or in the scientific laboratory, that can be done by using the lasers. So that can be done by using firstly by the Raman spectroscopy. We know that in the Raman spectroscopy the laser beam falls on the material and scattering, that is a Rayleigh scattering on the Raman scattering, that is done from the given material. So that is main application is done in the 2D materials. We know that for the 2D material the Raman spectra is important to analyze what kind of material that is get formed. So that is done by using the Raman spectroscopy, in which laser is used as an important part. Next, the laser induced spectroscopy can be done. Atmospheric remote sensing that can be done by using the laser, and many of the optics phenomena, like if you want to analyze the synthesized material at the nanoscale level, that can be done by the laser, because laser beams are highly intense. Next is the laser technology that can be used in the geology, seismology. That means in order to understand the atmospheric physics. So in order to understand this atmospheric physics at the atmospheric level, that can be done by using the LiDAR technology, in which laser is used as an important component. Next is the holography. That means if we want to study the 3D pictures of the material, that means you want to convert 2D to 3D to analyze the pictures in the 3D, means we know that in our pictures that is taken by the 2D, that is in the 2 dimensional only. But when you want to convert this 2D pictures to the 3D picture, the holographic technique that is used. So in the holographic technique, the main component that is laser is used. In the astronomy, the lasers can also be used in order to understand the stars and the different galaxies. So for that the laser that can be used. Also we know that in the military applications, the laser rays are also used. How the weapons are used and how they can be modified by using the laser. So that can be used. The laser guns are also used. The next is a LiDAR, that is a light detecting and ranging. And in the radar and the LiDAR, they are combiningly used technologies in order to understand the radio waves, or in order to understand the radio weapons or the war weapons. So that can be used by using the laser. So these are the applications of laser. So beyond these applications, the lasers can also be used in some of the techniques, like when you want to understand the materials and also to understand the synthesis, and in case of an applications part, when you want to understand what kind of the material that is synthesized in the physics laboratory, that is like the thin films which is get formed And what are their phases? Phases of the material, their thickness, what is the thickness of the materials which is get formed. So that can be also clearly understand by using the laser technology. So in some of the cases, like when you want to study the things at the spectroscopic level, so that can also be understood by using the laser. So lasers are highly applicable when you want to understand the material, synthesized material at the 2D level and also at the 3D level. So that is a major outcome which is synthesized in the physics laboratory in order to get our desired results. Okay, so this is about the application of laser, how the lasers they are widely used in the different kind of areas like communications, in the industries, for cutting and welding, and then also in the military application, and also in the physics laboratories, how you can use a laser in order to analyze the synthesized material. Thank you. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe this video, and also you can press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.